All right, today we're diving into some really cool technology, stuff that lets us see a world that's usually totally hidden from us. We're going to look at how one company, Raytron Microelectronics, is basically making the invisible, well, visible.
So let's just start with this one question. What if you could actually see heat? I don't mean just feeling it. I mean literally seeing it, like it was a color or a light. Imagine that for a second. How would that completely change the way you see the world?
I mean, it would be like getting a brand new superpower, right? You'd see the world in a completely different light. You could spot the lingering heat from a footprint, or find a cold draft from a leak in your wall, or even see someone hiding in pitch black darkness. And the wild part is, this isn't science fiction anymore. This is exactly what thermal imaging does.
Okay, so let's get into it. Before we can really get how this tech works, we've got to talk about the limitations of, well, us, our own eyes.
You know, the crazy thing is, the light our eyes can see, it's just a tiny, tiny sliver of what's actually out there. Think of it like a huge radio dial. We're only tuned into one station. There's a whole universe of information all around us. Heat, specific gases, things moving in absolute darkness. And we are just completely blind to all of it.
So the big question is, how do you bridge that gap? How do you see what's invisible? Well, that's where the company we're looking at today, Raytron Microelectronics, comes into the picture. They've basically developed a whole new way of seeing.
At the heart of it all is something called infrared thermal imaging. And what that really means, in simple terms, is it's a technology that can grab all that invisible heat energy that literally everything gives off, and it translates it into a picture that we can actually understand. It's like a translator for heat. You're literally seeing temperature. And Raytheon isn't just one of many companies doing this. They're a real leader in this space, especially when it comes to developing the absolute core of the technology. We're talking the tiny sensors and chips that are the engines behind this whole new way of seeing. So what's their secret sauce? How did they get to be a leader in this? Well, their big advantage comes from mastering the entire process. I mean, everything, from the ground up, basically from sand to sight. And they say it themselves. Their whole strategy is about mastering the core tech across the entire industry chain. And that's a huge deal. It's a massive claim, because it means they're in control of every single critical step along the way. And believe me, this chain is not simple. It's super complex. You start with the brain, designing the integrated circuit. Then you have to actually build the heart of it, this microscopic sensor. After that, you've got to package it all up and test it. And then, and this is crucial, you have to develop the smart software, the algorithms, that take all that raw heat data and turn it into a sharp, useful image. And you can really see the payoff of having all that control when you look at this timeline. I mean, check out this pace of innovation. It's relentless. They started with a 17-micron detector back in 2015, and from there, they have just consistently been shrinking the pixel size, hitting one world first after another. And that brings us all the way to this year, 2024, and their latest breakthrough, the world's first 6-micron detector. 6 micrometers. That is just unbelievably small. But okay, why should you care about that number? What does 6 microns actually mean? Well, think about your phone's camera and the whole megapixel thing. It's the exact same idea. The smaller you can make each pixel, the more pixels you can cram onto a sensor. And more pixels means higher resolution. Simple as that. You get a much sharper, way more detailed thermal picture. But here's the thing, seeing heat is only one piece of the puzzle. There are other kinds of invisibility out there. And it looks like Raytheon has a whole toolbox full of different sensors, with the right tool for each specific job. So for instance, if you want to see heat signatures, perfect for things like night vision or on a drone, you use their long-wave infrared sensors. But what if you need to see reflected light to inspect something like a computer chip? For that, you'd use shortwave IR. And then there's this really specialized stuff, sensors that are specially cooled and tuned to see specific gases like methane. That's absolutely critical for industrial safety to spot leaks. And what's cool is they offer this tech in different forms. You can get just the core component, that fundamental detector chip you see there, or you can get the whole package, a fully integrated camera module. It's basically a plug-and-play thermal eye all ready to be dropped into just about any device you can think of. Okay, so we've got the tech, we get the basics of how it works. Now this is where it gets really interesting. Where does this power to see the invisible actually make a difference in the real world? Where does it become useful? Honestly, the applications are pretty much everywhere you look. We're talking industrial stuff like measuring temperature on a factory line. We're talking drones, security and surveillance, finding those invisible gas leaks, inspecting huge solar farms for bad panels, even in things like laser ranging. Let's just look at a couple of quick examples.
So you see this one here? This rugged-looking camera module? This is the kind of heavy-duty gear you'd find in a serious security system. It's the kind of thing that can see straight through pitch-black night, smoke, or thick fog. No problem.
And then you've got the other end of the spectrum. Look how tiny this module is. It's so small and light. It's absolutely perfect for putting on a consumer drone, giving it thermal vision, or even building it into a handheld device you could just slip into your pocket. And take this one for an industrial setting. Imagine being able to spot a dangerous, totally invisible gas leak from way back at a safe distance. Or you could have a drone with this camera fly over a massive solar farm and instantly pinpoint exactly which panels are broken just by looking at their heat signature. Super efficient.
So all of this kind of points to one big final idea. What is the future of seeing actually going to look like?
Well, the trend is absolutely clear. These sensors are getting smaller, they're getting more powerful, and critically, they're getting cheaper every day. And what that means is that thermal vision is shifting away from being this super specialized, expensive tool for experts, and it's becoming something that can be built into, well, pretty much anything.
And that leaves us with one last question to think about. As this incredible power, this superpower to see the invisible world of heat and gas starts to literally fit in the palm of your hand, what new problems are we going to solve with it? What are we going to choose to see next?